Let us discuss a program to print the message hello world n times. Here n equal to 10. Here we use the loop instruction to create the iteration. For that we are keeping the value of n in CX register. The CX content will be automatically incremented by 1 when the loop instruction executes. And the iteration continues until CX value is greater than 0. That is, when CX reaches 0, the iteration will stop. Here our data segment, its name is my data. Inside this we have declared n and our message msg1. db means defined byte. So this is byte, a byte data. msg1 db hello world. Then you can see the dollar symbol in assembly language. In 8086 assembly language, the end of a string is indicated by the dollar symbol. So you have to put this dollar symbol to indicate the end of a string. It will not be put automatically by the assembler. Then here this data segment ends. Then the code segment starts. The first segment assumes CS colon my code, comma DS colon my data. That means we are directing the assembler. Assume is an assembler directive. We are directing the assembler that there is a segment named my code and it should be used as the code segment of this program. And there is a segment called my data. It should be used as the data segment of this program. Then you can see the label assigned to the first executable instruction of this program, and this label is used at the end. End is an assembler directive which will indicate the physical end of the program, and along with this assembler directive we are specifying the label assigned to the first executable instruction in this program. So on seeing this, the assembler will understand this is the first executable instruction of this program. Okay, then move AX comma my data, move DS comma AX. By these two statements, we are initializing the data segment register points to the data segment of this program. We are doing it in two steps because it is impossible to assign any segment register directly with a 16-bit value. So first we are moving the logical address of data segment to AX register, then AX register to DS register. Okay, so this way we can initialize any segment registers. These two lines are for initializing CX register to n, which will be used by the loop instruction. Then we will be preserving the CS content by push instruction, because the interrupt call int1h at this line may alter the value of CS content. We have no idea which are the registers used by the interrupt function to display a string. So we have to preserve our data kept in CX register. For that we are pushing CX register to stack. After printing the message, we will be popping the CX value from the stack. Then these are the three lines to print a message. We are using DOS interrupt, that is to1h. It is a collection of function. Each function has an ID. Here we are using the function with ID 09h. This number should be in AH register and the offset of the message to be displayed should be in DX register. Okay, so this is done in these two steps. Then we are invoking DOS interrupt call to1h. And after that we will pop the value of cx, then loop instruction is executed. It will automatically decrement cs content by 1. If it is not 0, the new value of the cs register is not 0, it will transfer the control to this label. This is a backward reference. You can see this here. Okay, so control will be transferred from this point to this point. Again, the content of cs register will be preserved. Then the message will be printed. So we are moving this offset of msg1 to dx every iteration, because the interrupt call may change the value of dx. Okay, once cx is 0, the iteration stops and the execution control comes here. Then these are the lines to stop the execution or terminate the execution. Move AX, 4600H means AH will be loaded with 4C, the function ID. Then 00H will be in AL register, that is the return value. Then we are calling dose interrupt int21H. So this will terminate the execution of the program. Here the end of code segment. Then this is the physical end of the program. So N is an assembly directive which indicates the end of the segment. End is an assembly directive which will show the end of the program. Along with this directive, we have to specify the label of the first executable instruction. Okay, let us try to translate this and run this. Link your program. OBJ file. Okay, the exe file from dir. You can see the exe file. Okay, let us execute that loop.exe. You can see hello world printed 10 times.